All right, we're going to do our digital lesson for Unit 5, Lesson 1. So let's check it out.
How old is the wheel and axle? If you said more than 5,000 years old, you'd be right. The wheel and axle was an important invention because it made many hard tasks much easier to accomplish, such as moving heavy objects or grinding wheat and corn for food. It allowed a small axle in the center to turn a larger wheel on the outside. This increased the amount of work that could be done, like grinding more grain or traveling greater distances. To see some modern wheels and axles in action, click on the highlighted areas on the picture. When you are done, click the next button to learn more about this and other simple machines. When early humans invented the wheel and axle, people quickly learned to use this simple machine to make carts and chariots. With every small turn of the axle, the larger wheel connected to it would turn and move the cart a greater distance than the small axle would travel. Now people could travel longer distances to places that were further away. Do you think they ever imagined people would one day be traveling in super-fast race cars? The axle in the center of these wheels are turned by a very powerful engine. The axle turns the wheel and moves the race car at even greater speeds along the track. Because the wheels are so much bigger than the axle, they allow the car to move really fast. Wheels are still used to grind grains today and to do many other jobs. The machine in this video is called a lathe. It uses a really powerful wheel and axle to help make things. Like other wheel and axle machines, the small axle turns the larger wheel, increasing its speed and transferring the power from the engine to the axle and then to the outside of the wheel. I wonder why they're pouring water on the axle. Perhaps it needs to be cooled.
Do you think that creates a lot of friction and heats it up? I bet it does.
Early carts were pulled or pushed in the direction people wanted to go. The carts moved slowly, and turning around was not easy. Today, steering wheels let drivers steer exactly where they want their vehicle to go. In this example, a large steering wheel turns a smaller axle, causing the wheels to move. The larger steering wheel means it takes less effort to make the wheels move. Welcome to the lesson, What are Simple Machines?, where you'll learn about 3 simple machines. You'll also find out about work and how simple machines make tasks easier. The vocabulary terms for this lesson are work, simple machine, lever, fulcrum, wheel and axle, and pulley. Click each term to find out more about it.
So work is the use of force to move an object across a distance. We see here some different things are doing the work to move this boat-looking thing. All right, let's go back. A simple machine is any machine with few or no moving parts that needs only one force applied. Okay, so there are more complicated machines, and we will learn some more about those as we go on. But this week we are talking about simple machines that only need one kind of force applied, maybe a pull or a push. Okay. A lever is a type of simple machine, and it's made up of a bar that pivots or turns on a fixed point. And I think we'll see an example of that as we move on with the lesson. The wheel and axle is a type of machine that is simple machine that's made up of a wheel and an axle that turn together, like the steering wheel. The fulcrum is the balance point on a lever that supports the arm but doesn't move. I think we'll see that later. And last type of simple machine is the pulley, made up of a wheel with a rope, cord, or chain around it. Okay, so like this turning part up here, that's the wheel of the blind. And then the chain or the cord, see how they're pulling it and that's turning the wheel and moving the blinds up. Oh, it's gonna, there we go.
Long ago, Archimedes, a Greek scientist and inventor, wanted to move a ship by himself. He used machines, pulleys, to move the ship by himself. Such machines can make work easier to do.
So some simple machines help the work go faster. Some simple machines are just to make the work easier, and a pulley makes the work easier.
Field hockey is fun, but did you know that when you hit the ball, you're doing work? Click the images to find out more about work and simple machines. This player is having fun hitting the ball. When he hits it, the ball moves in the same direction as the force from the hockey stick. The force from the hockey stick causes the movement of the ball. Scientists call the use of a force to move an object in the direction of the force work.
So did you know if you play basketball or baseball, really more baseball, sorry, than basketball because you're hitting something, or hockey or anything like that, that you're hitting a ball, um, or golf, that's work. Did you know you were doing work while you were playing a game?
A simple machine has only a few moving parts or sometimes no moving parts at all. When you use a simple machine, you apply just one force to the machine. A lever is one kind of simple machine. An oar is a type of lever. The captain of this boat uses simple machines to steer the boat. The steering wheel is a wheel and axle that changes the direction that the boat travels. The wheel and axle is a simple machine. The handle that the captain moves up and down to control the boat's speed is an example of the simple machine called a lever. Simple machines are everywhere. This fishing pole is a lever. The crank on the fishing reel is a wheel and axle. A sailboat also uses simple machines to make sailing easier. It uses pulleys to raise the sails. Pulleys are a kind of simple machine. A crank may be used to pull the line holding the sails. This crank is a wheel and axle. There are also levers on a sailboat.
So some types of transportation devices use more than one kind of simple machine. The sailboat uses a pulley. That's what we see here. Do you see how that looks sort of like the same system as what we saw on the blinds? It's just facing the other directions. It's upside down.
A lever is a simple machine made up of a bar that pivots or turns on a fixed point. Click the images to find out more about the different types of levers and how they make work easier. The oar of a rowboat is a lever. Like other simple machines, the oar is used to apply a force to move an object over a distance to do work. A lever uses a force to move a load. The lever is supported on a pivot point called a fulcrum while moving an object. The object being moved or lifted is the load. When a person pushes or pulls on the lever, the push or pull is the force applied to the lever.
Okay, so take a look at this picture right here. It kind of shows us the different parts. So you see the little block that the lever is hanging out on? This right here is going to be the fulcrum, okay? It doesn't move, but the lever is resting on it because that is what it kind of helps it pivot back and forth. So she's applying the force by pushing it with her finger, and the work is, as she pushes with her finger, the books are lifted.
A hammer is a lever when it's used to pull a nail out of a piece of wood. The fulcrum is where the hammer rests on the wood. The person pulls on the handle to apply the force. The lever applies a bigger force on the nail.
Okay, so I wonder what the fulcrum is here. All right, Do you see where the lever is resting? It's resting on the wooden piece of block. So where the lever is touching the block, that's the fulcrum as it pulls the nail out. It makes that work easier than just grabbing it with your fingers.
This wheelbarrow is a different type of lever. The fulcrum is the axle. The person pulls up on the handles to apply the force. The wheelbarrow makes the force bigger, so a person can lift and roll a heavier load. Tongs are another kind of lever. The fulcrum is at the end where the two arms of the tongs are attached. You squeeze the middle of the tongs to apply force. The tongs make your force smaller, but the ends of the tongs move over a larger distance. So you can grab a bunch of lettuce or a big burger.
Okay, so this one it looks a lot different than the other levers, but it still acts as a lever. This part right here where it's attached is the fulcrum, okay? That because it's not moving up here at the top. You apply force right here on the handles and they move a small distance, but they're able to grab a much larger piece because of the way they're spread out at the bottom.
Remember that scientists define work as the use of a force to move an object over a distance in the direction of the force. Click the image that shows work being done.
Okay, let's see which one is showing work. Pushing a closed door. No?
That's not quite right. There's a
See the
force, but the
difference?
door doesn't move in the direction of the force.
Okay, so she is applying force here, but there is no movement happening. So for it to be called the scientific definition of work, the movement has to happen in the direction of the force. And so that's not work. All right, trying to lift the weight, if he doesn't lift it, it's not work. Let's see what they say. Yeah.
Not quite. There's a force
Okay.
applied by the weightlifter, but the weight isn't moving in the direction of the force.
So just like trying with your muscles, if there is no movement, even though it makes your muscles tired, there's a force. The force is what makes your muscles tired, but the work would only be if you were able to lift it. Okay? Holding a tray, what do we think? Is the tray moving in the direction of a force? Let's see. I'm not sure. Yeah.
That's not it. There's a force holding up the tray, but the tray isn't moving in the direction of that force.
Okay, you see the difference here? So if I have a tray on my hand, all right, I am carrying it this way, but the force is what's holding it up. It's not going up. Now, if I'm doing this, then there is something called work in science, okay? But just holding it still, not work. So I think the only one has to be, boom.
You've got it. There's a force lifting the space shuttle and moving it upward. You know that work involves both using a force and an object moving some distance in the same direction as the force. Cars include many simple machines, including a wheel and axle. A wheel and axle is a simple machine made of a wheel and a rod, called an axle, that turn together. The wheel and the axle are permanently attached to each other. Click play at the points along the bar to find out more about wheel and axle machines. A wheel and axle is a wheel with an axle attached to the center of the wheel. The axle and wheel turn as one unit. Here, the steering wheel of a car is attached to an axle called the steering column, which turns to steer the car. The steering wheel and the steering column together are a wheel and axle. The radio volume knob is another example of a wheel and axle. The knob is a wheel that's attached to a rod. The rod moves a switch behind the dashboard. It's easier to turn the knob than it is to turn the rod by itself. A heater control is another wheel and axle.
So there must be some sort of knob inside there that controls the heat. So when you turn this knob to the right, the heater turns up. All right.
Did you ever try to lift something and find out that
this one, and we're going to come back to it because I am almost out of time for my screencast. So we're going to have two parts to this one today, but you don't have anything to turn in today.